we just mentioned that a fraction will increase if you increase the numerator or decrease the denominator. It works the other way. If you want to decrease a fraction, you decrease the numerator or increase the denominator. So we're going to use those thoughts. These are what's rolling around in our thoughts as we walked in the door. See our thought clouds. You didn't know I could read your minds. So let's do the first problem. Yesterday we introduced this formula. It should be floating around in your notes. So we stopped there and we're picking it up right at that point. So draw a car. The car has a velocity 21.0 meters per second, and the car is traveling toward you, and you are still. The horn has been engaged, so the horn has a frequency of 355, and the speed of sound in the current air conditions is known. I'm not going to make you calculate it from the temperature. 345 meters per second. So that's the data on this scenario. Can you find it? It's all in this orange area right here. And guess what the question is? Find the frequency you hear. That's you there. Detailed picture of you. So write down that scenario. If you get it done before your classmates, you get the picture done and the details done, go ahead and try to feed it into the formula where you think the numbers go. And I'll be catching up with you in a second. Alright. Car, 21.0 meters per second. It's in motion. It's moving toward you. You are still. The horn is emitting this frequency. What do you hear it in? Speed of sound is 345. Find the frequency that you hear. So, first of all, to start this problem, you have to decide, before you even go to the formula, will the pitch be higher or lower than what is being emitted? What do you think, Zach, from what we've said about this sort of thing? Pardon?
Higher.
Right. We already said that if either the source or the hearer or the observer are coming toward each other, the pitch is higher. So we're expecting the number to be greater than 355. So expect higher. So that will help you decide where you need to use plus or minus. So first decide that. If they're moving away from one another, it's going to be lower. Alright, so let's go in. We're looking for the frequency observed. I'm asking you, find the frequency you hear. So that's the observed frequency that you hear. The true frequency was given. What was it?
355.
Alright, so right here, I'm going to put 355. I'm just going to put it on top of the pieces here in this formula. Alright, so let's go down the road. Alex, what is the velocity of the sound?
Velocity of sound is 345
Right,
meters per
so
second.
notice that appears in two places. So I'm just going to go ahead and put it in, 345 and 345. Does this color show up in the video, Alex?
Sure does.
Alright, cool. Alright, now we come to MK. What is the velocity of the observer? It is, and usually, I think in all of our problems, either the observer or the source is zero. Like if it's the factory blowing the whistle, the source of the sound would be zero. But on this one, the observer is still. Where is she? There. All right, he or she. All right, so we have a zero there. So when there's a 0 there, it doesn't matter if we pick plus or minus, because plus or minus 0 is going to be the same answer. So I'm just going to ignore that plus or minus. However, down here, I have to pick one or the other. And the velocity of the source is known, so MD, what's the velocity of the source? So that's the source of the sound.
21.
Right, that's the car. The car is the source of the sound, and it was given as 21. So the only thing left is for me to pick plus or minus here. Does someone have, Brian, what do you think? Because we're expecting a higher number, what do we want to do in the denominator to make this whole thing a higher number? Do we want to put a plus between these two or a minus? It is, right. It is a minus because of this thinking here. Remember, to increase a number, one of the choices is to decrease the denominator. So we're going to use the minus sign. All right, do you see why this formula gets a little tricky? Because you have to decide what to use right in the middle of it. So go ahead, tippy-tap that away. This is a fraction, 345 over 345 minus 21. Whatever that is, times 355. So I need an answer. You have it? Tap away. Share it with me. You get it? Before you get it first, and then we'll verify.
1.06. Okay, sure, we'll go there.
I think this came out to 1.06 for me.
Yeah. Oh, you
All
multiply
right,
it.
so that is 1.06, but then we have to multiply it
Oh, yeah,
times
378.
355.
Yeah, I got 378.
What are we getting?
378.
378, I heard. And that is a frequency, so we're in hertz. Did it go up? It did.
It did.
So
Ooh.
we're going to hear a higher one. So this formula
I like this formula.
is not so bad. All right, can you try this one all by your lonesome? All right.
And this little life just missing. With slants and notes I caught yesterday. Alright. And yes,
Oh,
I was singing that song, and then the high note came, and I literally killed it. I was singing out loud, like it was just me, like these two people, and I was like,
All right, you try this one.
and they were like, okay, that's pretty good. I was like,
The town siren goes off.
before I started, that song be allowed for like,
401 hertz.
came on, I was like, I got the microphone, and I was like, started dancing. And I was like,
Person in the car travels away at 34.0 meters per second. So what's a town siren look like?
The firehouse.
Okay, mine's more like one of those hurricane or tornado sirens. Alright, so I have a town siren. The car is going away from it at 34 meters per second.
Just like the purge sound.
You watching a movie?
401 hertz is being emitted. That's the true frequency. And what else do I need to tell you? Speed of sound is going to be the same in air.
You're gonna die. It's like favorite science.
We're going to use that number again. 345.
Have a five, like top five. Listen, take it out and look like
Yeah.
you're on there. So.
And I think that's all I need to tell you. So find the frequency heard in the car.
I have to figure out.
Alright, write down the formula and fill in the numbers as you
I'm
go.
trying to push for like a bunch of things.
It'd be like, hey, we're gonna go meet Jesus in Nazarene. Like, if they came to meet Jesus in DC, and they'd be like, who's going to my house? It's Jesus, and I just went around his house.
Let me peek at it.
Wait, I'm still writing the problem down. Hold on.
Right, saying that's so. That's what you got.
You want to start by what do you expect?
You're still finding or frequency observed, right?
Right. Frequency heard.
Are you ever gonna have us find something else in the problem? or is
Yeah,
it-
sometimes.
Okay.
You got an answer?
Darn.
No, but why in the last one were you expecting a higher frequency result?
We had to analyze the situation, and the car emitted the sound, and it's moving toward the person that's still. So as you go
Oh, you
toward the
changed it up on
person,
me, dog.
you're
Wait a
running into
minute.
your own
Wait.
sound, and it's bunching up the crest, so you hear
Velocity
it.
of the observer.
So you have
What
to
is the
decide
car?
from the scenario whether the
The car
frequency
is the
goes up
observer, right?
or down. Zach, you got anything yet? M?
Wait. Velocity true.
Alright, pretty good.
Holy crap, that's a real big number. It's probably. Oh wait, I did the wrong thing.
Alright,
Wait, hold on.
alright.
0. Wait, you would want it to be lower, right? Wait, Miss Powell.
Yeah.
What'd you get?
Aren't
What'd
you
you
still expecting it to be higher?
Here we have the sound and
Oh, I think
the
I.
car's moving away.
Yeah, but
Oh,
So
we
as
supposed
it
to add
moves
it?
away,
but it's still like in front of
Oh, I
it.
just subtracted.
yeah, but the sound
Oh,
as,
sorry, the top.
Okay,
as
so
it's
you want it
moving
to be-
away, so it's going to be further apart from the sound waves.
Yeah.
So they're going to come out in like this, but he's going to be running through them in such a way that they're going to be further
To
apart.
316.
From his perspective, because he's moving away, he's going at the same direction that the waves are, so they're going to be further apart.
Wait,
So the
1,
frequency
plus or
is
minus
going to
do you
lower.
subtract them?
Traffic at 345 minus 30.
All right.
Why don't you use 4
So
1?
MM,
Wait, hold on.
what is the true frequency?
The whole answer to the problem?
Yeah, what's the true frequency? What should I put
Oh,
here?
401.
All right, what's the velocity of the sound?
345.
I notice that's the same on the bottom. What's the velocity of the observer?
34.
All right, this time we have a velocity of the observer. He's in the car and it's moving away. And what is the velocity of the source of the
0.
sound? All right, so I told you one of them's always going to be 0. So we don't care about this plus or minus. What about this one? Do we want plus or minus up here? Because
Minus.
we want the number to go up or down. We're expecting a higher or lower frequency when they're going
Lower.
up lower.
Yeah.
So what will keep this lower? The
361.
plus or
Got it.
Minus.
Right.
That's what-
Very good.
that's
Sorry.
what
All right. When you tap that out, I heard this number floating around.
Yeah, 361. That's what I got now.
Alright. Very good. All right. It's time for you to do 2 from the book. So we'll do 2 from the book and 2 from the practical. Well, they're all 4 from the book. So Oyo's 11.3, 11.4 for starters. Yeah. Is it time? Yeah. All right, we're gonna go ahead and shut down as we start our work.
local station
So
today.
we're doing